All right, section 12-3, inscribed angles. All right. So we're going to write the noun or verb to identify how intercept is used. So defense tries to intercept a touchdown pass. This should be a verb. The y-intercept of a line is the y value at x equals 0. This is a noun. Cryptographers intercept and decipher code messages. This is a verb. The x-intercept of a line is the x value at y equals 0. This is a noun. All right. So inscribed, related word is circumscribed. The definition, inscribed means written, marked, or engraved on. Circumscribed means encircled, confined, or limited. So in math, an inscribed angle is formed by two chords with their vertex on the circle. All right, so number 5, this would be an example of an inscribed angle. Number 6 would be an example of a circumscribed. Number 7 would be an example of a circumscribed. Number 8 would be an example of an inscribed. All right, to underline the correct word to complete each sentence. Angle ABC with endpoints A, B, and C on a circle is an inscribed angle. An intercepted arc is between the sides of an inscribed angle. All right, theorem 12-11, inscribed angles theorem. So the measure of an inscribed angle is half the measure of an intercepted arc. So suppose that measure of arc AC is equal to 90 degrees. Then the measure of angle B would equal 1/2 the measure of arc AC, which would equal 45 degrees. So the measure of angle B is 1/2 the measure of the arc. So suppose the measure of our angle B is 60 degrees, and we know the arc is twice the measure of that angle, which is going to be 120. Okay. So let's encircle what is the measure of angle A. So I know the sides of angle A are chords, and the vertex is on circle O. A is an inscribed angle, so I can use the inscribed angles theorem. The measure of angle A is 1/2 the measure of the blue arc. So this equals 1/2 of 180, which equals 90. Okay, so some corollaries to 12-11. Corollary 1, two inscribed angles that intersect the same arc are congruent. Corollary 2, an angle inscribed in a semicircle is a right angle. Corollary 3, the opposite angles of a quadrilateral inscribed in a circle are supplementary. All right, so number 14, use true or false. Angle P and angle Q intercept the same arc. All right, P and Q, they're both 90 degrees. They both intercept the same arc. That's true. Okay, S, R, P, and Q intercept the same arc. S, R, P, and Q. No, they do not intercept the same arc, so that's false. TSR is a semicircle. TSR is a semicircle. That's true. PTS and SQR are opposite angles. PTS and SRQ, oop, nope, not quite. So this is false. PTS and SRQ are supplementary angles. PTS, and SRQ are opposite, right, and the quadrilateral, so those are true. Okay. Problem 2. Okay, so let's use justifications. To find the measure of angle 4, it's going to equal 1/2 of 60 plus 80, because that's the inscribed angles theorem. So 1/2 of 140 is going to give us 70. So circle the corollary we could use to find measure of angle 2. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So we know that the measure of angle 4 plus the measure of angle 2 equals 180 degrees. We just found the measure of angle 4. Subtracting 70 degrees, we get the measure of angle 2 equals 110 degrees. All right, so underline the correct word to complete the sentence. The dashed line is a diameter. So corollary you could use to find measure of angles 1 and angle 3. Angles inscribed in the semicircles are right angles. So the measure of angle 1 must be 90. The measure of angle 3 must also be 90. So if I know measure of angle 1 is 90, measure of angle 2 is 110, measure of angle 3 is 90, and the measure of angle 4 is 70. All right, 12-12. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So 27, suppose the measure of angle C is 50 degrees, then the measure of the arc is going to be twice that angle, which is 100. What if I'm working backwards? What if I knew the arc was 80? So then the measure of the angle is going to be 1/2 the arc, which would equal 40. So the diagram at the right, I know ray BC is tangent to O at B. So that means the measure of arc ADB is 180. So the measure of angle ABC is 90. All right. So in the diagram to the right, KJ is tangent to circle O. What are the values of X and Y? So we're going to circle the arc intercepted by JQL and underline the intercepted one by KJL. Okay. All right, intercepted by JQL. JQL, so intercepted would be JL. All right, intercepted by KJL. KJL would be right here. So that would be this one as well. So by the inscribed angles theorem, measure JL is equal to twice 35, which equals 70. By 1212, X equals 1/2 of measure of arc JL, which we know is 35. So the value of X is 35. So underline the correct word to complete the sentence. QL is a diameter, so QJL is a right angle. All right, fill in the blanks here. So we know that the angles, the sum of the three angles in a triangle have to equal 180. So 90 plus y plus 35 equals 180. Adding these numbers together, y plus 125 equals 180. Subtracting 125, y equals 55. All right, so classmate says that measure of angle A is 90 degrees. What is your classmate's error? So is diameter AC a side of angle A? Yeah. Is A inscribed in the semicircle? No. What's your classmate's error? So the error is in thinking that an angle with a diameter as a side intercepts a semicircle. Measure of angle A does not equal 1/2 of 180 degrees. And that's the end of this section.